Okay. Hello. Today our group will be presenting on Uber data analysis and the cancellation crisis surrounding it.
I'm Tiago Lake, everyone.
I'm Krista Boswell.
I'm Brax Galbraith.
And I'm Avery Harris.
So to start, Uber was founded in 2009 in San Francisco and evolved from a small car-hailing concept into one of the world's largest ride-sharing platforms. It began as a simple idea, but over time it reshaped urban transportation and took over taxi industries worldwide. The app leverages GPS technology and dynamic pricing, all while connecting riders and drivers instantly, making travel faster and more convenient. Over time, Uber expanded into new services like Uber Eats and other micro travel options, but its core focus remains car transportation. The overall platform relies on trust. Riders expect drivers to show up, and drivers expect riders to commit. When either party cancels, it disrupts the balance and creates unnecessary delays, weakening the confidence in the platform's reliability. In recent years, these cancellations have become one of Uber's most persistent and disruptive operational challenges. Even small spikes in the cancellation trips disrupt the driver's immediate plans and slowly erode the confidence in the company over time. Our project analyzes real-world data and a range of variables to uncover why cancellations happen and how we can predict them. The factors include trip distance, which can influence driver acceptance, driver ratings, which may correlate with decision patterns, customer ratings, which often reflect reliability, booking times, which can impact availability, and payment methods, which can increase risk for drivers. The main objective is to identify patterns so Uber can intervene early and boost customer trust.
So let's talk about the real issue here. When an Uber ride gets canceled, it might not seem like a big deal, but those cancellations actually have a pretty big ripple effect. Every time a driver cancels or a rider cancels, that's wasted time, wasted gas, and a lot of frustration on both sides. And the bigger problem is trust. If riders keep getting their trips canceled, eventually they stop depending on Uber. They start thinking, why bother? I'll just use Lyft instead. And the data actually reflects that. Lyft has been gaining ground in customer satisfaction because they've improved their ride-sharing features and reduced cancellations. For Uber, this isn't just an inconvenience. It affects loyalty, the brand reputation, and long-term revenue. It costs way more to attract a new customer than it does to keep an existing one. So losing regular riders over unreliable service is a major business problem. That's why understanding cancellations matters. They aren't just annoying, they're harming the system, frustrating users, and pushing people toward competitors. To really understand what's going on with these cancellations, we used a combination of data and real-world research. The main data came from a large-scale data set with over 150,000 Uber ride records from the NCR region. This data set included everything from ride distance to driver ratings to time of day and specific reasons that a trip was canceled. Having all of that information helped us to see patterns that you wouldn't just catch from personal anecdotes. But we didn't want our analysis to just be numbers. So we also looked at news articles and reports that put the human experience into context. For example, Travel and Tour World talked about why Lyft is now beating Uber in customer satisfaction. Tech Business News shared stories from riders who were hit with cancellation fees or felt like customer service wasn't supporting them. The Federal Trade Commission even took action against Uber, accusing them of misleading users with billing and cancellation practices. DM News also raised an interesting question. If passengers get charged for canceling, should drivers too? The debate shows how complicated and emotional this whole cancellation issue really is. So by combining the hard data with real stories and industry reporting, we were able to understand both the statistical side of cancellations and the actual human frustrations behind them.
All right. Now, for our project, we followed the CRISP DM process, which is basically a step-by-step framework for helping solving real business problems with data. So we started this with business understanding, which the core issue here is that we looked at what that Uber has a high number of ride cancellations, which makes the service feel unreliable for customers. When cancellations happen frequently, it hurts customer satisfaction and long-term trust. So our main goal at this stage was to understand why these cancellations happen, so we eventually could find ways to reduce them. So next was our data understanding, which we analyzed a data set of about 150,000 Uber rides to see what information we had to work with. This included things like ride distance, driver and customer ratings, booking times, payment types, and whether or not each ride was canceled. We explored the data to get a sense of which of these factors might be connected to cancellations and which ones were worth focusing on. Then we moved into data preparation, which this is where we cleaned up everything and fixing missing or inconsistent data and organizing the columns and standardizing formats so the data was usable for modeling. We also created new features like grouping rides by time of day to help our models identify patterns more clearly. So then now getting into part two of this process. So after preparing the data, we moved into the modeling phase, which here we tested several machine learning models in Python to predict the risk of ride to to predict the risk of a ride being canceled. The models looked at a pattern between variables like ride distance, ratings, and booking times. Our main goal was to estimate the likelihood of a cancellation before it actually happened. Then came evaluation, which is where here we compared how well each model performed to see which one made the most accurate predictions. We used common metrics like accuracy and precision to evaluate overall performance. We also looked at which variables had the strongest impact on cancellations. For example, things like longer trip distances or lower driver or rider ratings showed a higher connection to cancellation rates. Which overall, this step helped us figure out not only which model worked out best, but also which factors mattered most for understanding and potentially reducing these cancellations.
Great. Now that we've walked through our modeling process and evaluation, I'm going to move into what our data actually revealed. Slide 8 breaks down the key patterns we discovered when analyzing the 150,000 Uber rides. About 20 to 25% of all rides in this data set ended up being canceled, which is a major reliability problem for Uber. We also saw that cancellations peak during rush hours, which is particularly between 7 to 10 a.m. and 5 to 8 p.m., which makes sense because these are the times when demand is the highest and wait times naturally increase. Vehicle types also play a big role. Auto and e-bike rides had noticeably higher cancellation rates, which suggests these services are more vulnerable during peak periods or in high traffic zones. When we looked at cancellation reasons, customers mostly canceled because drivers weren't moving towards a pickup point or they were facing long wait times. On the other hand, drivers often cancel due to personal or vehicle related issues or concerns like poor customer behavior. These findings helped us understand that cancellations aren't random. They follow pretty consistent patterns driven by time, distance, vehicle type, and wait time. This gave us a strong foundation for predictive modeling, which we'll discuss in the next step. Once we understood the patterns in the data for slide 9, we moved into the modeling phase. We tested three machine learning models: logistic regression, random forest, and gradient boosting. Our goal was to predict whether a ride would be canceled before it actually happens. After evaluating each model using metrics like accuracy, precision, recall, F1 score, and ROC AUC, we found that our best performing model achieved over 85% accuracy, with all models scoring above 0.85 ROC AUC. This means our models aren't just guessing, they're reliably scoring or reliably distinguishing between rides that will complete and rides that are at high risk of cancellation. The random forest model stood out because it also helped us interpret the most influential features. Some of the strongest predictors we had were booking time, ride distance, vehicle turnaround time, and the type of vehicles booked. These factors consistently shaped cancellation outcomes. Overall, the model showed that the cancellations are predictable and that Uber could proactively intervene, for example, by assigning more reliable drivers or adjusting the pickup radius before a cancellation even occurs. Now to move on to our ethical recommendations to improve this situation for Uber. We developed several of these recommendations focused on making Uber more reliable while being fair to both riders and drivers, since it's both important. First, we suggest implementing a more balanced cancellation policy, one that acknowledges drivers' need for flexibility but also protects riders from unpredictable fees or repeated cancellations. Next, Uber could introduce an in-app cancellation risk prediction tool. This feature would use insights from our models to evaluate each booking in real time and match high-risk riders with more reliable drivers. This would reduce friction during pickup, especially during these peak hours. We also recommend shrinking the pickup radius during busy periods to reduce long wait times, which were one of the biggest driver reasons drivers of customer cancellations. Increasing transparency is another key step. Showing more realistic wait times, driver supply levels, and traffic conditions would set clearer expectations for riders. Finally, it's important that Uber maintains strong communication and respects drivers' autonomy, especially when a ride is unsafe or unprofitable. Overall, these recommendations are designed to build trust, improve efficiency, and help Uber reduce one of its most damaging issues, which is cancellations. Overall, our analysis shows that Uber's cancellations issues are measurable, predictable, and solvable with data-driven strategies. By combining real-world reports with our modeling insights, we're able to offer recommendations and strengthen reliability and improve the experience for both riders and drivers. We are excited with what we came up with, and we hope you enjoyed our presentation. So thank you.